Have you ever stopped to think about how incredible your computer is, or your phone, or even your watch? These devices are packed with tiny, tiny switches that help us do everything from sending messages to friends across the world, to watching videos of cats playing the piano. They can solve math problems faster than any human ever could, and store entire libraries of books in a space smaller than your fingernail. For decades, we have been making these computers smaller, faster, more powerful. We have been pushing the limits of what these amazing machines can do. It's all based on a very simple idea, an on or off switch repeated billions of times. But what if we are reaching the end of that road? What happens when we can't make those switches any smaller? Scientists and engineers are always looking for the next big thing. The next leap feels like science fiction. But it's real. It's called quantum computing. This isn't just about making computers a little bit faster, it's about a whole new kind of computer that works in a fundamentally different, mind-boggling way. It follows the strange and wonderful rules of the quantum world. The world of atoms and tiny particles that make up everything. Imagine a car that could drive on roads, fly through the air, and tunnel through the ground, all at once. That gives you a sense of how different a quantum computer is from your desk computer. It's not just an improvement, it's a revolution. Let's peek inside a regular computer, the kind you're using right now. At its very core, everything it does is based on a very simple concept: the bit. A bit is the smallest piece of information a computer can handle. Think of it like a light switch. A light switch can only be in one of two positions. It can be on. It can be off. There is no in between. In the world of computers, we represent off with the number 0, and on with the number 1. Every single thing your computer does, from showing you this text to playing a song, is broken down into a long sequence of these zeros and ones. Your computer contains billions of these tiny switches called transistors. They are so small that millions of them can fit onto a chip the size of a postage stamp. When you type a letter on your keyboard, the computer translates that letter into a unique pattern of bits, a specific sequence of zeros and ones. For example, the letter A might be represented by the bit pattern 01000001. A picture is just a massive grid of these bits, with each bit telling a tiny dot or pixel whether to be dark or light. It's a simple system, but when you have billions of these bits working together at incredible speeds, you can create amazing complexity. Now, let's dive into the weird and wonderful world of quantum mechanics. This is the science of the super small, the world of atoms and particles. Down at this level, the normal rules of physics that we see every day don't quite apply. Things can be in multiple places at once and can be connected over vast distances. A quantum computer harnesses these strange properties to work its magic. Instead of a bit, which is like a light switch, a quantum computer uses something called a qubit. A qubit is the quantum version of a bit, and it is fundamentally different and much more powerful. Think about a coin. A regular bit is like a coin lying flat on a table. It can either be heads, 1, or tails, 0. It's one or the other with no other options. A qubit, on the other hand, is like a coin that is spinning in the air. While it's spinning, is it heads or tails? Well, it's kind of both at the same time. It has a certain probability of landing on heads, and a certain probability of landing on tails. A qubit can be a 0, a 1, or it can be in a state of superposition, which means it holds a combination of both 0 and 1 simultaneously. It's only when we measure the qubit, when we stop the spinning coin and force it to land, that it settles into a definite state of either 0 or 1. So we have these amazing qubits that can be both 0 and 1 at the same time, and can be spookily linked together. What does that actually mean for solving real-world problems? Quantum computers aren't just faster versions of regular computers. They are a completely different tool for different kinds of tasks. They excel at problems with a huge number of possibilities that make classical computers grind to a halt. They don't check answers one by one, they look at all possibilities at once. One exciting area, medicine. Another, materials science. Discovering a new drug, creating a new material, a more efficient battery, a stronger alloy. Molecules are quantum systems. Simulating them accurately is incredibly complex. Classical computers make many approximations. Quantum computers operate on the same quantum principles as molecules, so they could simulate them perfectly. That could let scientists design medicines tailored to someone's DNA and invent materials with properties we can only dream of today. As we look toward the horizon, it's clear that quantum computing is not just a scientific curiosity, it's a technology that holds the key to unlocking a new chapter in human progress. It's important to remember that we are still in the very early days of this technology. The first quantum computers are like the first classical computers from the 1940s. They are huge, expensive, and require a team of experts to operate. They are sensitive to the tiniest disturbances, like vibrations, temperature changes, which can disrupt the delicate quantum states of the qubits. Building stable, large-scale, and fault-tolerant quantum computers is one of the greatest engineering challenges of our time. However, the progress being made is honestly breathtaking. Researchers and companies around the world are racing to build better and more powerful quantum machines, steadily increasing the number of qubits and improving their stability. We are not likely to have a quantum laptop on our desks anytime soon. For the foreseeable future, these powerful machines will likely be accessed remotely through the cloud, with scientists and businesses tapping into their immense power to solve specific, complex problems. Your everyday computer will still be perfect for email, browsing the web,